guys, welcome back. So what we're looking at today is 3.5, divide and conquer. So let's go ahead and jump right in. All right, so what we're looking at here first is solving the linear equations. So they aren't all actually linear, despite the fact that it calls them linear. So keep that in mind as we're solving. So on number 2, we want to take and add the 8 over. So we'd have 1/3 x equals 8. To get rid of the 1/3, we need to multiply by 3. So x equals 24. So for 1, 2, and 3, it's just a simple linear equation. Now for 4, 5, and 6, these are quadratics, and we need to get them into factored form. So for x squared minus 16 equals 0, this is the difference of two squares. So we'd have x plus 4 and x minus 4, both set equal to 0. When we do that, it just changes the signs. So -4 and +4 are your two solutions for what x is. On number 5, we have x squared plus 4x plus 3. The only way we can factor that is x plus 3 and x plus 1, the two things that multiplied to give us 3 and add to give us 4. Now, just like on number 4, we'd set each of these equal to 0, so it just changes the sign. So we'd have -3 and -1 for our solutions. And this last one here, we'd have x minus 2 and x minus 3. Together, the two negatives multiply to give us a +6, and they add together to give us a -5. So then you can solve from there. Now, what you may notice is 7, 8, and 9 are already in the factored form. So that means all you're doing is setting each part equal to 0 and solving, okay? So that won't be too bad. All right, the next thing that we're looking at is dividing polynomials. Dividing is your key word for this lesson. Dividing. So when we divide, this is can be tricky. It isn't too bad. Hopefully you won't think it's too bad. So we're going to do number 10 and 11 together. We're going to do a few of them. So what do we have to do to x to get to x cubed? Well, we'd multiply it by x squared. So we put an x squared up here. So this is just like long division with numbers. It's just now we're looking at it with variables. So x squared times x gives us x to the third. X squared times 1 gives us x squared. We subtract these just like before. These cancel. -3 minus -1 is going to give us a +2 because -3 minus negative is +1. So we have a -2x squared plus 6x plus 11. So now what do we have to do to x to get to -2x? Well, we multiply it by -2. Sorry, that should actually be a plus. Whoops, I made a mistake. So that's a plus. So this, sorry about that, guys. So even teachers do it. -3 minus 1 is going to give us a -4x. So what do we have to multiply to x to get to -4x squared? Well, that would be a -4x. So that gets us our -4x squared when we actually multiply, -4x. So these cancel. 6x minus -4x is going to be 6x plus 4x, which is 10x plus 11. What do we multiply x by to get to 10x? 10. So we have 10x plus 10. Subtract, those cancel. 11 minus 10 is 1. So our answer is x squared minus 4x plus 10, remainder 1. So the multiplication statement is x plus 1 times x squared minus 4x plus 10 plus 1 over x plus 1. So anytime we have a remainder, we just put the remainder over what we were dividing by, and that gives us how we can represent that. All right, this next one here, we have x minus 5, and we're taking x cubed minus 9x squared plus 23x minus 15, and we're dividing it by the x minus 5. So same idea. What do we multiply x by to get to x cubed? We multiply it by x squared. So we have x cubed minus 5x squared. Those cancel. Negative 9 minus negative 5, so really negative 9 plus 5 is going to give us a negative 4x squared plus 23x minus 15. So what do we multiply x by to get to negative 4x squared? Negative 4x. So negative 4x squared. Negative 4 times negative 5 is a positive 20x. Subtract, that cancels. 23 minus 20 is 3x minus 15. What do we need to multiply x by to get to 3x? That would be 3. So we end up with 3x minus 15. So this one works out perfectly. So our multiplication statement is x minus 5 times x squared minus 4x plus 3. So it's just rewriting what we divided by and what we got for an answer, what our quotient is. So it'll be the same idea for 12, 13, 14, and 15. You're just dividing them. All right, our next section, describing the features of a variety of functions. Graph the following functions and identify the key features of the functions, including domain, range, intervals, where the function is increasing and decreasing, intercepts, maximum, minimum, and behavior. So lots of things that we can identify here. So here we have x squared minus 9. So we're going to put our x-axis. I know my x-axis is so wobbly. We'll go there, y-axis right here. So we need to be down at negative 9 to start. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is our starting point. Now if we plug in 1, 1 squared is 1, minus 9 is negative 8. So there's those 2 points. Plug in a 2, 4 minus 9 is negative 5. So 1, 2, 3, 4, 5. There's that one and that one. Plug in a 3. 3 squared is 9. 9 minus 9 is 0. All right, so there are some values for us to see our parabola. There we go. And then, whoops. I know it's wobbly. And there we go. So there's our parabola. Now, the domain. This is going on infinitely in each direction. So it's negative infinity to positive infinity. The range, though, the lowest this is ever going to go is negative 9, but it will go up to positive infinity. It's increasing, so notice it's going up on the right-hand side. It's going down on the left-hand side. So it's increasing from 0 to positive infinity, and it's decreasing from negative infinity to 0. The y-intercept, well, that's what we started with, was 0, negative 9. Our x-intercepts were right here at 3 and negative 3. So negative 3, 0, and 3, 0. All right, this next one is a linear equation. If we wrote this as a y equals, so it'd look a little more common for you, it'd be y equals 3x plus 1. So you'll start at 1 on the y-axis, you'll go up 3 and over 1 each time. For 18 and 19, take and plug in values to take and solve. All right, and the last two, you're given graphs and you want to take and identify the features. So for 21, since it's a little weird, the domain is each of these points. So the domain is negative 1, 0, negative 1, 0, 1, 2, 3, 4, 5, 6, because it's individual points. The range is some fraction, so we can say, I'm going to tell you it's 1/8, and then that'd be 1/4, 1/2, 1, 2, 4, 6, 8 and 16. Increasing, it is never increasing. Decreasing from x when x is an element of the integer system. From -1 is less than x is less than or equal to 6. Y-intercept is right here at 0, 8. X-intercept, it's never actually on the x-axis, so it is none. So be very careful. The other one will be much easier because it's not a collection of points, but you will have multiple increasing, decreasing portions of it, okay? All right, if you guys have any questions, feel free to ask. Have a great day. Bye, guys.